All right, welcome back, Algebra 1, to another math assignment. This is 5-2 direct variation. So our objective for today is to write and graph an equation of a direct variation. So let's get right into it. All right, so for direct variation, basically what we're looking at here is a relationship that can be represented by a function in the form y equals k of x, or sorry, not k of x, but y equals k times x, where k does not equal 0, okay? And then k is constant, okay? So k is going to be a constant number, all right? It won't be a second or a third variable, I guess. It'll just be a constant, okay? So we're going to go ahead and we'll just go straight down into problem 1. All right, and it says, does the equation represent a direct variation? If so, find the constant of variation. All right, so for this one, we have, for A, we've got 7y equals 2x. All right, so 7y equals 2x. And then you're going to solve the equation for y. Okay, so to do that, you'll divide both sides by 7. We end up with y equals 2 over 7 times x. All right, this is in the form of y equals k times x, okay, where k would be 2.7. All right, so this one is a direct variation, okay. And then the constant of variation, okay, so if we go back up here, the constant of variation, all right, is just k. All right, so we can define the constant of variation. Whoops. Give me just a sec there. All right, so as I was saying, before I made that mistake with whatever, the highlighter, k, the constant, is equal to 2/7. All right, now if we try problem B, we can do 3y plus 4x equals 8. We can subtract the 4x from both sides, so we'll end up with 8 minus 4x. All right, and then we can divide everything by 3. Remember, when you do that, you got to divide everything on both sides by 3. So we end up with y equals 8 minus 4x over 3, or 8 over 3 minus 4/3 x. All right. Now, you can see that we can't write this as y equals k times x. And the reason for that is we have right here, we have a constant outside of k. Okay. So since you cannot add 8/3 onto negative 4/3 x, this one is not an example of a direct variation. Okay. All right, so hopefully you're good on that one. I want you to go ahead and try got it problem 1. Okay, it says, does 4x plus 5y equals 0 represent a direct variation? And if so, find the constant of variation. So give that one a try, and then we'll move on. Okay, so for problem number 2, we have writing a direct variation equation. It says, suppose y varies directly with x and y equals 35 when x equals 5. What direct variation equation relates x and y? And then what is the value of y when x is 9? All right, so we got 2 parts that we got to do. First, we got to find out the equation. Okay, so since we know that it's direct variation, because it says suppose y varies directly with x, okay? Since we know that's true, we can start with y equals k times x. All right, then we can go ahead and plug in our y and our x, which are given to us. So it says y equals 35, and then it says x equals 5. All right, now all we got to do is go ahead and substitute, or sorry, we just did the substitution. We just got to solve here. All right, simplify. That's what I was trying to say, was simplify. So you can divide both sides by 5 to get k by itself. We're going to end up with 7 equals k. All right, since we know this, we can now plug it into our original equation. So we have y equals 7x. All right, so again, that's 7. We know it's the same thing as k, so we can take out k and put 7 in its place. All right, so now we have y equals 7x, and then it asks us to find, so that was the first part of this problem. Part 2 is to find what is the value of y when x equals 9. Okay, so then we just substitute 9 for x and solve. We have y equals 63. All right, so that's really it for that problem. Go ahead and try got it problem 2. It's going to be a similar problem. All right, so problem 3 is a real world example, kind of. It's more of a real out of this world example. See what I did there, because it's about space. All right, so as soon as you are able to gather yourself from the hysterical laughter, I'm sure, that I just put you in, go ahead and we'll look at problem 3 together. So I'll give you a second to pause the video so you can stop laughing at the hilarity of my jokes. Okay, so now that you're calm and collected again, we have space exploration. So the weight on Mars, y, varies directly with weight on Earth, x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. Okay, so for part A, it says, what is an equation that relates weight in pounds on Earth, x, and weight on Mars, y, not wife. All right, so we're going to start again with y equals k times x. All right, and then we can just plug in for x and y. It says that our weight on Mars is 50. Okay, weight on Mars is our y value. So then our x value would have to be 130, which is our weight on Earth. Okay, again, we would just solve this. So if we divide both sides by 130, I don't know what that is, so I'm just going to trust what they've got, which is that it's approximately 0.38, and that's what we're going to have for k. All right, so y equals 0.38x is going to be our best representation of this problem. Okay, so then we have for part B, what is the graph of the equation in part A? You'll make a table of values. All right, so what you're going to do here, that was a bell, is we're going to plug in for x and y. All right, and then they do 0, 50, 100, and 150. All right, so there you would just, sorry, I got distracted. I had students come in to talk to me. So anyway, you would just go ahead and plug in your values for x, or sorry, yeah, your values for x, and then find y, right? So for 0, you do y equals 0.38 times 0, which would then give you 0. So y equals 0 for that one. And then for 50, you'd have y equals 0.38 times 50, which would then equal, I think it's 0.19 probably, or 19. Yeah, not 0.19. That would be 19, and then so on, and that's how you would solve that one. All right. Okay, so then if you were to draw your graph using those values that we got, which is right here, you could graph it like they do right here. And as it says, the points form a linear pattern, and then you would draw a line through them. Okay, so since it goes through the origin, this is the other way that you can tell that it has a direct variation. If it goes through the origin, so if it goes, if it's linear and it goes through the origin or 0, 0, this means a direct variation. All right, so that would be a good thing to have written down. That'll make it really easy to tell whenever you are looking at a graph. Okay, so that is that problem. Okay, we will go ahead and move on. I don't want to make you do got it problem 3, so we'll just go ahead and move on to problem 4 here in the notes. All right, so this is writing direct variation from a table. Okay, so for the table, or for the data in the table, does y vary directly with x? If it does, write an equation for the direct variation. All right, so basically what you're going to do is you're going to look at the table and you're going to compare these ratios. All right, so we're going to look at it as rise over run still. So for the first one, we'd have 6 over 4, which is 1.5. 12 over 8, which is 1.5, and then 15 over 10, which is again 1.5. All right. Since each one is the same, that means we do have a direct variation. All right, and then the equation for it would be y equals 1.5 times x. All right. And then if we looked at B, you can see if we did the exact same thing, you'll see that the values that they got when they did those ratios, we've got negative 1.6, 2.4, and 0.4. Obviously, those are not the same. Okay, since they are not the same, even though it is linear, okay, so notice it is linear, but since they're not the same, that means we don't have a direct variation, okay, because those are not proportional to each other. All right, and again, if you were to look at this one would actually go through the origin. So if you did 0 for x, you would also get 0 for y. Whereas this one, if you did 0, I'm not really sure, just looking at it, what that inequality is, but it would not go directly through the origin. Okay, go ahead and look at got it problem number 4. And then after you have done that problem, that will be it for this video. So I will see you guys in class.